We're going to use a table of values so that we can graph f of x equals x. Do you know how to do that? -9 goes in. -9. -5 goes in. Do you get the drill? They're all going to be the same, yes? Okay, so let's just copy this all down. And we're going to plot it. Okay.
Is that a 0 or 6?
Oh my, that is a 0. Okay. So -9, 9, -9. I don't have that on here, but I'm going to do -5, -5.
No.
-2, -2, -1, -1, -1/2, -1/2. It's hard to do the -1/5, -1/9, so I'm going to skip to 0, 0. You know it would have been on 1/2, 1/2, 1, 1, 2, 2, 5, 5. Does everybody see what this is going to be? Not just a line, a diagonal line at the 45, yes? You should try to use a ruler. Okay, just like our previous graphs, we are using this to graph what we want. We graph what we know to make it into what we want. Does everybody understand that? What we want is 1 over x. Not y equals x, we want 1 over x. So, how do I turn x into 1 over x? Flip it. Flip it, yes? Yes. So does everybody see that I'm going to take my f of x is equal to this x. So does everybody see with my g of x, this is really going to be, I'm going to take my f of x, which is this previous number here in the second column, and I'm going to reciprocate it. Okay, we're going to see what happens here. I'm going to use a different color pen because the blue is not what I want. Does everybody understand that? Okay, so let's reciprocate -9. What do we get? -1 over 9. Yes? Yes.
How many bigger spaces?
-1 over 5. Now this is on my graph, so I'm actually going to plot this. So at this -5, -5 junction, it's now going to be -5, -1/5. Does everybody see? So approximately right there. -2, what does -2 become? 1 over 2. So at -2, when x is -2, my y value is going to be -1/2. So right there. -1, I'm going to flip -1. What do we get? -1 over 1, which is just -1. Like the sign doesn't change, but -1 over 1 is still -1. Yes? So that's at the exact same spot it was. And we will soon figure out there's a particular name for that. Okay, what happens when I flip -1/2? I get -2 over 1 or -2. So this half right here becomes -2. Does everybody see that? Okay, so I will repeat what's going on here. The x's are not changing, so I'm not going left or right or anything like that. I'm taking the height and reciprocating it and then putting it where the new height is. So I'll repeat what I just did. The height, when x was -5, the height was -5. The -5 became -1/5. The height of -2 became -1/2. The height of -1 became still -1, right? The height of -1/2 now dropped to -2. So what about a height of -1/5?
-5.
It would become -5. So if I could actually find where that height of -1/5 is, somewhere in there, it would drop to -5. Do you see that? So yeah, let's put a dot there. Somewhere where -1/5 is. It's going to be approximate at this point, right? What does -1/9 become? -9. So if you can even be smaller than -1/5 and get -1/9, that would drop all the way to there, really close to the y-axis, right? It's coming. It's coming. So let's reciprocate 0, a height of 0.
0.
This was 0/1. We're flipping it. We get 1/0. Can we divide by 0? No, this is the biggest rule in math you cannot do. You cannot divide by 0. It's the biggest no-no. It's what's called undefined. Undefined. So if I have a region that's undefined, I'm going to represent that by what's called a asymptote. I will spell it for you. Asymptote. This is called a vertical asymptote. I can't spell vertical. Let's go there. Vertical asymptote. It means there is an undefined region right there. And the way I indicate that is by putting the dashed line. It has to be dashed, not solid. Okay? Dashed. Okay, 1/9. We reciprocate it. It becomes 9. So somewhere in here is 1/9. Let's put it to 9. Stay about there. 1/5. Reciprocate.
5.
We get 5. So 1/5, I don't know. We're kind of guessing. So it's going to be, say, about there. 1/2. We reciprocate it. So here's where my 1/2 is. There's where my 2. 1. 1. Again, it stays the same. Remember, -1 stayed the same and +1 stayed the same. 2. 1/2. So here's the height of 2. Does everybody see my height of 2? It's dropping to 1/2. Yes? 5. 1/5. So the height of 5 becomes 1/5. The height of 9 becomes 1/9. So way up here, it's going to go to there. What about 100? 1/100. What about 1,000? What about 1,000,000? Okay, so does everybody see the farther and farther and farther I go to the right and I reciprocate it, the closer and closer and closer I get to the axis, which is a height of 0. But it'll never reach it, it'll never cross it, because how can a positive, when you flip it, become negative? So what's happening here is on the right here, it's curving and it's getting close and close and close, but it's not actually crossing. So we're going to put an arrow here, and the way I indicate that behavior, that it's getting closer and closer and closer to that x-axis, it is what's called another asymptote. It's not actually going to touch 0. So this is what's called a horizontal asymptote. Okay, and so we indicate this, especially if it's on the axis, because it's hard to see a dashed line on the axis, so always put it past where that graph is. Okay, so let's look what happens between 0 and 1 on my blue. Does everybody see? These are all small numbers, right? And when I flip small numbers, what do they become? big numbers. So the smallest number is as close to 0 as I can. When I flip it, it becomes the absolutely hugest number you know. What would that be?
993.
Yeah, so the biggest concept of a number that you know is positive infinity. So what's happening here is this is going and it's trying to reach the highest it can, but it actually doesn't reach it. It'll never get there. So it's never going to cross over because that's undefined there. So it's going to approach this as close as it can, but never actually get there. So let's look at the third quadrant here, what's going on here. It's very similar, except now we're talking about negative numbers, because when we flip negative numbers, it's still going to be negative, right? So big numbers here, like if I were to flip a million, negative a million way down there, it would become negative 1 over a million, right? Very small, very close to 0. So do you see? We're going to get the same thing over here, another horizontal asymptote. What's going to happen here between 0 and 1? That is a fractional amount, and I flip it, it makes it huge. How huge? It's going to be the biggest negative number you know. In theory, what would that be? Negative infinity. So there you go. Bada bing, bada boom. A line that a curve approaches that never touches is what's called a asymptote. Points, now this is a new term for you, and we'll use it in grade 12 as well. Points that remain unchanged through a transformation, that was the 1 and the negative 1, are called invariant points. So this is a new word, so now you know what it's called. So the domain of y equals x, that was the blue line. What would the domain be?
Negative infinity.
Negative infinity to positive infinity. What happened to the domain when I reciprocated it?
Positive infinity.
Look at the domain of my red. It's everything except 0. So how do you want to write that? Yeah, we can write it as a set notation if you want. X is an element of reals. X cannot equal 0. Okay, so if you want to write it that way, let's write this way then. So X is an element of the reals. Okay, range. Let's look at the blue. What's my range of my blue? What's my range? Negative infinity to positive infinity, or y is an element of the reals? What is my range of my red graph? Everything except there is no 0 here, right? So y is an element of the reals. Y cannot equal 0. What's the end behavior? That is the equation of asymptotes, if any. So for the blue, the bigger and bigger and bigger that x gets, what happens to y? No, blue, you guys.
It gets bigger.
It gets bigger, yeah. So as x gets bigger, y gets bigger. What happens if x gets smaller? Yes. It depends on how you say smaller. Smaller is bigger negatives, right? So y gets smaller. Okay, now let's look at the red graph. When x gets bigger and bigger, more and more to the right, what happens to my y? It gets smaller, smaller, smaller. When x gets bigger, y gets smaller. What happens when x gets smaller?
It gets bigger.
No, let's look at the graph. Smaller is x going to the like really small numbers, negative to the left. Yeah, y gets smaller, right? Okay. So the end behavior at x equals 0. The behavior at x equals 0. What's the behavior at x equals 0 here? For the blue. Y equals 0. Yeah? What's the behavior at 0 and 1 over x? Well, on the right of 0, it goes to positive infinity. On the left of 0, it goes to negative infinity. So we'll have to kind of break it down. Oh, yeah, this should be bigger. Thank you. Okay. So, okay. So when x goes to 0 from the right, what happened? Y went to infinity. When it went to the left, sorry, I didn't give enough room. Y went to negative infinity. The invariant points were 1, 1, and negative 1, negative 1. Those are the ones that didn't change. So we are now going to graph y equals 2x. Do you remember how to graph that? You put a point on 0, up 2 over 1. Does everybody remember how to graph a line that has a slope of 2? We should. Okay, so this is my f of x equals 2x. I'm just going to label it so we know which one's which. So now we're going to determine the reciprocal equation. If I write y equals 1 over f of x, and f of x originally was 2x, what's my new equation? 1 over 2x. Does everybody see? So we're now going to graph y equals 1 over 2x. So what's the technique here? So the technique is wherever the height was 0, that became what when we flipped it? One over 0, which was undefined, which was represented by an asymptote. So do you see? We're going to have an asymptote again right here. The next technique is we need to look for the invariant points. So maybe I'll write this down. So number 1, find the 1 over 0 becomes a vertical asymptote. Okay? The second step is find the invariant points. And the invariant points are the plus or minus 1 height. Because when I flip plus 1, it stays as plus 1. Now, if you look at this, my height of 1, because I didn't use a ruler, is right here. It's kind of in between. Does everybody see that? There's my height of 1s. So put a dot where your height of 1s are, 1 and negative 1. Because when I flip that, they stay the same. Okay, so the next concept is small y's become, when I flip it, big y's. And big y's become small y's. So, where's my big y's? Right here. There's my big y's. I'm going to flip it. So what's going to happen? It's going to become small y's. What's happening between 0 and 1? Those are my small y values. So what is that going to become? Big.
Asymptote.
It's going to flip up and go against the asymptote because it's going to try to get to infinity. Same thing happens over here, except I need to put what kind of behaviors displayed right here? Asymptote. Okay, so where do we have big negatives? Right here. I'm going to flip these big negatives. What does that become? Small negatives. Again, I have the asymptotic behavior. What happens between 0 and 1? They're small. I flip it, it becomes big. And there's my graph. Answer. Again, what's my domain and range?
Negative infinity.
For my domain and range of my blue? It's not negative infinity to positive infinity because at some point it can't be 0. XER, x cannot equal 0. What's my range? It can't be everything.
YER.
Yeah. Very good. Okay. Does everybody know how to graph f of x equals 3x minus 6?
No.
How do we do that? We put a point on -6 and we go up 3, 1, 2, 3 over 1. Then I go up 3, 1, 2, 3 over 1. Then I go up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. So there is my line, and I'm going to label it f of x equals 3x minus 6. I'm going to change colors to get my answer. Does everybody see? If f of x equals 3x minus 6, and I'm told to graph 1 over f of x, what am I actually graphing? 1 over 3x minus 6. So this is the technique that you're going to be graphing, is you choose what you know how to graph. I know how to graph a line. Then I make it into the function they're asking me to graph. The function they're asking me to graph is 1 over 3x minus 6. So I'm taking this line and I'm going to reciprocate it. So where is my first step? That is where y is 0. That's your x-intercept. So what's going to happen there? Where's the height of 0? Right there. What's going to happen right there when I flip it? It's not going to be there anymore. Because you can't, when you flip 0, you get 1 over 0. Undefined. How do I represent that? Asymptote. Does everybody see my asymptote is now at 2? Then's the next step. Ones, negative ones, invariant points stay the same. Bam, bam, stays the same. Find them, put the dots, don't move them. Because the height of 1, when I flip it, stays as 1. A height of -1, when I flip it, stays as -1. Where's a height of 1? Right there.
Bingo, bingo.
Stays there. Where's my height of -1? Right there. Stays there.
One is along the entire line.
But there's only one point where it hits the blue line.
Oh, that's easy.
I'm looking at the blue line here. These are all good. Okay, so now what happens when we get bigger and bigger and bigger and bigger and bigger on this blue line? It becomes smaller, like that. And then what do I get? A horizontal asymptote. What happens between 0 and 1 in the blue line? Those are small heights. I reciprocate small heights. What do I get?
Bigger.
Bigger. Biggest is positive infinity. Make it go to positive infinity there. Do you see that? Yes, don't cross the line. Don't curl away from the asymptote. The arrow can go across the asymptote. The curve cannot. You will lose marks, okay? So what happens when I'm going to negative infinity, bigger and bigger negatives, and I reciprocate it? It becomes smaller and smaller. And we get our other horizontal asymptote on that side. Between 0 and 1, if I reciprocate it, what do I get? Bigger negatives. There we go. What's the domain this time?
XER can't equal 2.
XER, x cannot equal 2. Very good. What's my range this time?
X equals 0.
Y can't equal 0. Does everybody see that? Because that's where I have, like if I'm going from left to right, I have to lift my pencil when it gets to 2 because there's nothing there, right? And then I keep going on my path. Or you can also look at this a different way. If I'm traveling on this graph, I get to the point where I get as close to it as possible, but I'll never reach it. It takes me away from it, right? No, I'm not saying the domain and range of the blue. I'm saying the domain and the range of my answer, which is my red, right? Yeah. Okay, next one. How do I graph f of x equals negative 2x plus 4? You put a point on 4, and then I go down 2 over 1, down 2 over 1, down 2 over 1. Yes? There is my f of x line. Negative 2x plus 4. Again, if I'm graphing 1 over f of x, I am graphing 1 over negative 2x plus 4. So I graph this negative 2x plus 4. What do I have to do to make it what I want? I need to reciprocate the y values. This takes a lot of practice, you guys. So, where's my height at 0? First step. Right here at 2. So what happens there when I flip it?
That's the asymptote.
The asymptote, a vertical asymptote, right? Yep. The horizontal asymptotes only describe the really big x's or the really small x's, just so you know. Okay, where's my height of 1? Right there and right there, negative 1. Does everybody see my height of 1 and negative 1? Those are called what again? Invariant points. They don't change. Now the concept of smaller becomes bigger and bigger becomes smaller, and then you're done. Smaller becomes bigger. Bigger becomes smaller. And there's our horizontal. Smaller becomes bigger. Bigger becomes smaller. Done. You see how easy that is to graph once you get it? Domain. What's the domain? X cannot equal 2 this time. What's my range? Okay. We good? Okay. Next one. How do we graph f of x equals x minus 3? Point on negative 3, then up 1 over 1, yes? Does everybody see that line? F of x equals x minus 3. Again, I am graphing y equals 1 over f of x, which is 1 over x minus 3. So just moving back to where we did our rational functions and we talked about NPVs. Does everybody see I have an NPV here? What is it? X cannot equal 3. What do you think happens graphically where we have that NPV? That's the asymptote. Look at that. Did you ever wonder where those NPVs come from? Well, that's that height of 0 here that becomes our vertical asymptote. You can't have an NPV, so that whole region is kind of blacked out or whited out or whatever you want to call it. It's got that vertical asymptote there, so you can't have any part of it. Do you see that? Okay, so 1s stay as 1s. Same thing over and over again. Smaller becomes bigger, bigger becomes smaller. Whoop, whoop. Horizontal, bigger becomes smaller. Oop, I crossed it. See, I would lose marks right here, just so you know. I crossed the x-axis, so I would lose marks. And you will too. And there you go. So it's pretty fast graphing once you get the concept and basically the steps of what to do. What's my domain? X is an element of reals. X cannot equal 3. What's my y? Y cannot equal 0.